we talked about inverses, right? And we talked about one-to-one functions, which pass the vertical and the horizontal line test, which means that their domain and range values are unique. They don't repeat. And we practiced finding if two functions were inverses through composition. We also found the algebraic inverse of a given function. And that led us here to example number 3. And we saw that its inverse wasn't a function. Remember, we talked about it's a square root with the positive and the negative. And whoopsies, it's not a function. That's bad. We need to be able to find the inverse that is a function. Do you remember why we came across this? There was something we talked about with the given. Steven?
If the given function isn't one-to-one, then the inverse won't be?
Won't be a function. Yes, good. If the given, thank you, isn't a one-to-one function, its inverse is not a function. Interesting. So, how do we combat that? Oh, we just don't find the inverse. No, we restrict the domain. So, think about this particular quadratic. It's a parabola. Does it open up or down? Jack? Up, thank you. How'd you know? How do we know it opens up?
Oh, sorry, I was stretching.
Don't let me interrupt the stretch, sir. My apologies.
Positive.
What's positive?
The 3.
Yeah, that a value, right? So we know this is a parabola that's going to open up. Now, in order for us to restrict the domain, we're going to have to find the vertex and pick either the left or the right side. Does it matter which one we choose? No. We just have to restrict the domain so that what we're finding the inverse of is a one-to-one function. Okay, remember that we do have this vertex at the bottom in HK form. So we'll restrict the domain based off of the H, since that is the X value. And this, leads us to page 2. Maybe, there we go. So we're gonna go in backwards order. Take a look at B. We see right away that it's a quadratic. Okay. Where does this parabola open? Opens up, right? Because the a value is positive. So we have this parabola. We need to restrict the domain. And we either need to restrict it to the left or to the right. And guess what? It doesn't matter which one you choose. Okay, I can't stress that enough. Pick one, left or right, doesn't matter. But what we need to find is the H value. In order to restrict the domain, you need to find the H value. If you need to, write that down. So, what is the H for this particular one? Aiden? 3, yes. Be careful. Sometimes you'll need to factor out the B value before you identify the H. You might want to write that down in case you struggle with factoring out the B value. In this particular one, we didn't have a B. So yes, we can identify our H is 3. Since quadratics are not one-to-one, in order to find an inverse function, we have to restrict the domain. Well, let's take a look as if we wanted to restrict to the left. If I'm going to restrict to the left of the vertex, that means that right away I'm going to state x is less than or equal to 3. Okay, if you're asked to find the inverse function of a quadratic, you must restrict the domain right away. And then everything's the same. We're going to switch the x and y. Okay, so switch x and y with me, please. So x is equal to 2 times y minus 3 squared minus 1. And then let's solve for y. So I'm going to add 1 to both sides. X plus 1 is equal to 2 times y minus 3 squared. And let's divide by 2. So we get the quantity of y minus 3 squared equal to x plus 1 all over 2. How do we get rid of a square? Because remember, we're trying to isolate y. What's the inverse operation of a square? Very good. Nice, everyone. Square root. So that leaves us with y minus 3 is equal to, when we're solving, right, when we're trying to find the unknown and we take the square root, what do we have to remember? So proud. Good work. Yes, the plus and minus. So we're going to have plus and minus the square root of x plus 1 all over 2. This little booger, this is what causes us to have the issue of our inverse not being a function. So we're going to have to address that in just a second. The final thing that we need to do to get y by itself is, yes, add 3. So we're going to put, just for now, plus and minus the square root of x plus 1 all over 2, and then plus 3 on the outside. So we restricted our x's to be less than or equal to h, correct? Yes? Yeah. So therefore, it's not plus and minus. We have chosen the negative side of this sideways parabola. When you restrict your parabola, your quadratic, to be to the left of the vertex, to the left of the axis of symmetry, your inverse square root will always be the negative. Okay, always, always, always. Now let's say, I like positive numbers. I personally would like to go to the right. Hey, you do you. So if you're going to restrict to be greater than or equal to h, the right-hand side, when you find its inverse, so now we're stating at the very beginning x is greater than or equal to 3, your inverse will be the positive version. Okay, again, the reason that we restricted the domain at the beginning is because our given function wasn't one-to-one. And in order for us to find an inverse that is a function, we had to restrict the domain. So we're only finding the inverse for either the left side of the parabola or the right side, not the full curve. Does that make sense, everyone? Yeah? Okay. Any questions on example B? All right, let's look at example A. It is a little bit different. What's the A value here? 3. Okay, so it's a positive 3, which means that the function we're finding the inverse for looks like that. Okay. Is this one-to-one? Yes. So we know that its inverse will be a function. We don't have to restrict the domain like we did the other example. Let's go ahead and switch x and y. So x is equal to 3 times the square root of y minus 4 plus 2. And let's isolate y. Let's subtract 2 to both sides, so we get x minus 2 is equal to 3 times the square root of y minus 4. And then we need to divide by 3, but, oh man, I don't really want to. Can I multiply by something instead? 1/3, nice. You can multiply by its reciprocal instead of dividing by 3. So I'm going to do that. We still have the square root of y minus 4 is equal to 1/3 times x minus 2. And now, what do we do to get rid of that square root? Ah, so good. Square both sides. So y is equal, nope, not yet. Y minus 4 is equal to the quantity of 1/3 times x minus 2 squared. Now we can isolate y by adding 4 to both sides. So the inverse, don't forget that -1 exponent, is equal to 1/3 times x minus 2 quantity squared plus 4. But we have a problem. Wah, wah. Just when you thought you were done. We have a problem because we found that its inverse is a parabola. Do these look like inverses of each other? No. One's half a curve, the other is the full curve. So if you're asked to find the inverse of a square root function, at the very end, you have to restrict the domain to the side of the curve that you want. And this all goes back to the a value. We want the positive side of the parabola. So I'm going to restrict this to say that x is greater than or equal to what? No? What's the h value? 2. The h value of the inverse, not of the original. We're restricting the parabola, not the square root. Does that make sense? Yeah, okay. So, big differences here. If we're given a quadratic and asked to find the inverse, restrict the domain at the beginning. If you're given a square root function and asked to find its inverse function, we restrict the domain at the end. Yes? Okay. Any questions? None yet. So